to travel? But what if you could travel through time? Today, let's look at solving one variable equations by traveling through time on a timeline. Tim is 8 years old. One day, he asked about his mother's age. When you are as old as me now, I will be 54 years old, replied his mother. How old is Tim's mother? Now, this question may seem a little complicated, but to understand it better, let's put it on a timeline. Let's say that this point on our timeline represents the time now. So let's put Tim and his mother on this timeline. Well, how old are Tim and his mother? The problem tells us that Tim is 8 years old. So now we know Tim's age. But what about his mother? Well, as you can see, the question asks us, how old is Tim's mother? So that means that we need to find how old his mother is. And since we don't know how old she is, we can assume her age by using a variable. So, let's assume Tim's mother's age by the variable A. So now, Tim is 8 years old and his mother is A years old. Now let's continue to read the problem. One day, he asked about his mother's age. When you are as old as me now, I will be 54 years old, replied his mother. So let's put this on our timeline. This point on our timeline represents sometime later in the future. And here are Tim and his mother. So how old will they be? Well, when Tim is as old as his mother now, and since his mother is now 8 years old, in the future, Tim will also be 8 years old. Well, when Tim is 8 years old, his mother will be 54 years old. So now we know Tim and his mother's age now and their ages sometime later. But the problem is asking us how old his mother is now. So in other words, we need to find the value of A. And to do that, we can set up a single variable equation. But how can we set up an equation? First, let's look at their ages now. Remember, the difference in years between Tim and his mother's ages will always be the same, no matter how old they are. In other words, the number of years between Tim's age and his mother's age will always be the same, no matter how old they are. So, let's find the difference between his mother and Tim's age now. To do that, all we have to do is subtract his mother's age minus Tim's age. This gives us A minus 8, which is the difference between his mother and Tim's age now. Well, what's the difference between his mother and Tim's age sometime later? Just like before, we can do his mother's age minus Tim's age, which gives us 54 minus A. So now we know the difference between Tim's age and his mother's age now and sometime later. But remember what I said. The difference between their ages will always be the same. So, to set up our equation, we can make A minus 8 equal to 54 minus A. So let's do that. Here is our setup equation. So now, let's solve it by taking out the parentheses. A minus 8 is equal to 54 minus A. Now, let's bring negative A to the left side of the equation. Next, let's take negative 8 to the right side of the equation. This gives us A plus A, which is equal to 54 plus 8. Now, let's simplify both sides of the equation. A plus A is 2A, and 54 plus 8 is 62. So, 2A is equal to 62. But we want to find the value of A. So let's bring 2 to this side of the equation. A is equal to 62 over 2, or A is equal to 31. So now we know that Tim's mother is 31 years old. But just to be sure, let's check our work. Now we know that when Tim is 8 years old, his mother is 31 years old, which is the time now. And sometime later, when Tim is 31 years old, his mother will be 54 years old. But how can we check our work? Well, to find the value of A, we solved this equation. And remember what this equation is. To set this equation up, we found the difference between his mother and Tim's age now and made it equal to his mother and Tim's age sometime later. So, to check our work, we can plug the value of A back into our equation. So, we can solve 31 minus 8 is equal to 54 minus 31. So let's start by looking at the left side of our equation. 31 minus 8 is 23. So the left side of our equation is 23 when we plug in the value for a. But what about our right side of the equation? Well, the right side of the equation, 54 minus 31, also equals 23. So, 23 is equal to 23, which is correct and proves that our answer is the right answer. Now, let's look at another example. Alison is 26 years younger than her father. Her father's age will be 3 times her age in 4 years' time. How old is Alison? Just like before, let's put this on a timeline. Here is our timeline. Let's suppose that this point on our timeline presents the time now. So how old are Alison and her father now? Well, the question is asking us how old Alison is. And the question also tells us that Alison is 26 years younger than her father. Well, since the question is telling us her father's age in reference to Alison's age, we can start by assuming her father's age by using a variable. So let's use the variable a. So Alison's father is a years old. And since Alison is 26 years younger than her father, her age would be a minus 26. So now we know Alison and her father's age now. Now let's fast forward 4 years ahead. How old will Alison and her father be then? Well, we know Alison is a minus 26 years old now. So to find her age 4 years later, we can add 4 to her age now. So a minus 26 plus 4, which we can simplify. Negative 26 plus 4 is negative 22. So Alison's age in 4 years would be a minus 22. But what about her father? Let's look back at the problem. Her father's age will be 3 times her age in 4 years' time. In other words, 3 times Alison's age now will be her father's age in 4 years. So, his age will be 3 times a minus 26. Remember, a minus 26 is Alison's age now. So now we know their ages now and what their ages will be 4 years later. But remember, we want to find how old Alison is now. And in order to do that, we need to find the value of A. So we need to set up a one-variable equation. But how can we do that? Remember what we looked at in the previous problem.
The difference
between her father and Alison's age will always be the same. In other words, the years between her father's age and Alison's age will always be the same regardless of how old they are. So, to set up an equation, let's start by finding
the difference
between her father's age and Alison's age now. Well,
the difference
is A minus 26. But what's
the difference
between their ages 4 years later? That would be 3 times A minus 26 minus A minus 22. And we can make both of those equal. So let's write this out in an equation. On the left side of the equation is
the difference
between her father and Alison's age now. And on the right side of the equation is
the difference
between her father and Alison's age 4 years later. So let's go ahead and solve this by first opening the parentheses. A minus A plus 26 is equal to 3 times A, 3A, and 3 times negative 26, which is negative 78, minus A plus 22. So now let's combine like terms on the left side of the equation. A minus A is 0. So this gives us 26 on the left side of the equal sign. Now, let's simplify the right side. 3A minus A is 2A. And negative 78 plus 22 is negative 56. Now, let's take 56 to the left side of the equation. And let's simplify it. 82 is equal to 2A. And if we take 2 on the left side of the equation, 82 over 2 is equal to A. Now, let's simplify. This gives us A is equal to 41. So now, we know that her father is 41 years old. But we want to find how old Alison is. And since Alison is A minus 26 years old, we can plug in the value of A. which gives us 41 minus 26, which is 15 years old. But just to be sure, let's check our work. We know that Alison is 15 and her father is 41 years old now. But how old will they be in 4 years? We can find out their ages to be able to check our solution. So let's do that. Starting with Alison's age. Her age in 4 years will be A minus 22. So let's plug in the value of A. 41 minus 22 is 19. So in 4 years, Alison will be 19 years old. But what about her father? Let's plug in the value for A. 3 times 41 minus 26, or 3 times 15, which is 45. So, her father is 45 years old in 4 years. Now let's go back and look at our question. The question tells us that Alison is 26 years younger than her father now. So, 41 minus 26 is 15. So that's correct. Now let's read the next part. Her father's age will be 3 times her age in 4 years' time. In other words, 3 times Alison's age now is equal to her father's age in 4 years. So, to check, we can do 3 times 15, which gives us 45, which is in fact her father's age in 4 years. Another way that we can check this problem is by substituting our value of A back into our equation and making sure it works. To set up our equation, we found
the difference
between their ages now and their ages 4 years later. So, 41 minus 15 is 26, which is
the difference
between their ages now. Let's look 4 years ahead.
the difference
Between their ages is 45 minus 19, which is 26. This tells us
the difference
between their ages is the same. So our solution is correct.